Admiral Dönitz never imagined America could launch a ship every day. Prologue: Nightmare Beneath the Atlantic. November 15, 1942. North Atlantic waters, 400 nautical miles west of Ireland. Korvettenkapitan Ernst Keller lowered his periscope, his eyes still aching from the glare of sunlight reflecting off the sea. What he had just witnessed couldn't possibly be correct. In 47 days of patrolling these waters with U-557, he had sunk 4 Allied merchant ships, a commendable achievement by Kriegsmarine standards. But the number he had just counted through his periscope rendered all those victories meaningless. 17 new cargo ships, he told his control room officer, his voice hoarse. In convoy HX-217 last week, we sank 4 vessels, but they've been replaced by 17 ships, and that's just a single convoy. This wasn't supposed to happen. According to the calculations of Befehlshaber der Unterseeboote, the U-boat command under Admiral Karl Dönitz, the submarine campaign was winning. In November 1942, the U-boat fleet had sunk 807,754 tons of Allied merchant shipping. That number far exceeded the shipbuilding capacity of any nation on Earth. By pure military logic, Britain should collapse within 6 months, strangled by the shortage of ships carrying food, fuel, and weapons. But something was wrong. Keller had noticed it over the past 3 months. The ships just kept coming. Not old ships being repaired, not neutral vessels being requisitioned, but brand new ships. Ships that looked identical. Ships with a square, crude, almost insultingly simple design. And they just kept coming, more and more, as if from some endless factory, an industrial machine that the German mind couldn't conceive of. In his war diary, later discovered in Kriegsmarine archives, Keller wrote, "We are killing sharks, but the ocean keeps spawning more. Something has changed in the equation. The Americans have done something we don't understand." He was right. America had done something no nation in history had ever done. They had industrialized the sea itself. Chapter 1: Dönitz's Mathematics of War. To understand the shock the Germans experienced, we must understand their absolute confidence in 1942. Gross Admiral Karl Dönitz, commander of Germany's U-boat fleet, was no dreamer. He was a cold, calculating strategist who had spent 2 decades perfecting a single theory of naval warfare, Tonnagekrieg, the War of Tonnage. The theory was simple to the point of cruelty. Britain was an island nation. Its survival depended entirely on millions of tons of goods transported across the Atlantic each month. Food from Canada, steel from America, oil from the Middle East, or from Africa. If this lifeline could be severed, Britain would starve and surrender without requiring an invasion. Dönitz's mathematicians had calculated precisely. Britain needed a minimum of 600,000 tons of goods entering port each month to sustain the war effort. If U-boats could consistently sink more than this figure, the war would be over. And in 1942, they were winning. In November 1942, U-boats had destroyed nearly 120 merchant ships. According to Germany's best intelligence reports, the combined shipbuilding capacity of Britain, Canada, and America was approximately 200,000 tons per month, less than what was being sunk. "We just need to maintain this pace," Dönitz told his staff at a December 1942 meeting. By calculation, Churchill will have to sue for peace by summer 1943. But there was a variable Dönitz hadn't accounted for. A variable that no naval expert in the world could have imagined. The Americans weren't just building ships the traditional way. They were mass-producing ships in a manner the world had never seen. Chapter 2: Henry Kaiser and the Crazy Vision. Henry J. Kaiser was not a shipbuilder. That was precisely what made him a genius. Born in 1882, Kaiser had spent his entire career building massive projects. Hoover Dam, the Golden Gate Bridge, Grand Coulee Dam. He was a construction entrepreneur, a master of large-scale logistics, of organizing thousands of workers, of moving millions of tons of materials. When President Roosevelt summoned American industrialists in fall 1940 to discuss war production, Kaiser arrived with a bold proposal. He could build cargo ships faster, cheaper, and in greater numbers than anyone had ever done in history. Traditional shipbuilders laughed at him. They spoke of centuries-old traditions, of the craft of metalworking, of engineers trained for years. Building a ship, they explained, required 6 to 12 months of meticulous work. Each ship was unique, handcrafted by skilled artisans. Kaiser shook his head. "You gentlemen are building ships the traditional way of 19th century craftsmen," he said. "I will produce ships the way Henry Ford does. Assembly line, standardized components, workers trained for specific tasks rather than all-around craftsmen." He added one more thing that made everyone in the room think he'd lost his mind. "I will launch a ship every day." Chapter 3: The Liberty Ship Revolution. The ship Kaiser proposed to build wasn't a new design. It was based on a British cargo ship design from 1879, a simple, reliable steam-powered vessel called a tramp steamer. The British had updated this design and called it the Ocean Class. But the Americans transformed it into a completely different industrial phenomenon. They called it the Liberty Ship. Specifications: length 441 feet, 134 meters. Beam 57 feet, 17 meters. Height 37 feet, 11 meters. Dead weight 10,500 tons of cargo. Speed 11 knots, 20 kilometers per hour. Engine triple expansion steam engine, 2,500 horsepower. Crew 44 sailors plus 12 Navy gunners. On paper, it was an ordinary, even outdated ship. Nothing breakthrough about the design. What was breakthrough was how it was produced. The welding revolution. Kaiser's most important and controversial decision was to completely abandon the traditional shipbuilding method of riveting and switch to electric arc welding. For centuries, ships were built by joining steel plates with thousands, sometimes millions of red-hot rivets. Each rivet had to be heated, inserted into position, held by a worker on one side, while another worker on the outside hammered it until it was secure. A traditional merchant ship could require 1 million rivets. This required teams of skilled riveters, usually 4 people per team, months of training to master, extremely dangerous and noisy work, slow speed. A good team could drive 200 to 300 rivets per day. Kaiser proposed welding, joining steel plates by melting them together using electric arc. This sounds simple, but the shipbuilding industry violently objected. The welds will crack in the cold water of the North Atlantic. Welding can't withstand the stress of ocean waves. It takes 10 years of experience to become a good welder. Kaiser replied, "I can train a welder well enough in 2 weeks." And he did. By simplifying the welding process, standardizing welds, creating templates and jigs, Kaiser transformed highly skilled work into quickly trainable work. Results? A welded ship needed 1/3 the workers of a riveted ship, 5 to 6 times faster, 600 tons lighter, no rivets, better watertight hull. Prefabrication, pre-made components. But welding was only the first step. Kaiser applied Ford's principles thoroughly. Prefabrication. Instead of building ships piece by piece at the shipyard, Kaiser divided the Liberty ship into sub-assemblies. Large sections produced complete in different factories, then transported to the shipyard for final assembly. A Liberty ship was divided into 250 large modules. Each module could weigh up to 100 tons. Modules included not just steel structure, but complete piping, electrical systems, fully finished cabins. For example, the entire crew quarters, including walls, floors, ceiling, beds, lockers, electrical systems, plumbing, were built complete in a separate factory, then lifted by giant cranes and lowered into exact position on the ship. The entire process took 4 hours instead of 4 weeks. The Kaiser system. 1. Steel mills. Rolling mills in Pennsylvania, Ohio, Illinois produced standardized size steel plates. 2. Fabrication shops. Hundreds of small shops across America received blueprints and produced individual parts: stairs, railings, doors, windows. 3. Module assembly shops. Large facilities assembled complete modules. 4. Shipyard. Only did final work, welding modules together. This system meant thousands of workers could work simultaneously on the same ship without crowding into the shipyard. It meant work could proceed 24/7, 3 shifts a day. Assembly line. Kaiser set up his shipyards like Ford's assembly line. Stage 1, Slipway 1, lay keel and main transverse frames. Stage 2, Slipway 2, assemble steel plates into hull bottom. Stage 3, Slipway 3, erect bulkheads and decks. Stage 4, Slipway 4, install engine and main systems. Stage 5, Slipway 5, complete cabins, upper decks, equipment. Stage 6, Slipway 6, paint and final inspection. Stage 7, launch. Each ship moved from stage to stage on a fixed schedule. When a ship left Slipway 1, a new keel was laid immediately. This system ensured all workers were always busy, with no downtime. Chapter 4. The numbers the Germans couldn't believe. In September 1941, Kaiser's Richmond shipyard in California completed the first Liberty ship, SS Patrick Henry. Time, 244 days from keel laying to launch. This was still an impressive achievement, much faster than the average 355 days for traditional shipyards. But it still wasn't fast enough. Kaiser continuously improved the process. December 1941, time reduced to 150 days. March 1942, 100 days. June 1942, 60 days. September 1942, 40 days. November 1942, average 30 days. And then, to prove what was possible, Kaiser organized a demonstration. SS Robert E. Peary, world record. On November 8, 1942, Sunday, at Richmond Shipyard No. 2, Henry Kaiser wagered his reputation. He announced that his yard would build a complete Liberty ship in 5 days. Traditional shipbuilders called it a publicity stunt. The press was skeptical. Even the government was doubtful. But Kaiser had prepared thoroughly. All 250 modules pre-produced. 4,500 workers specially trained. Hour-by-hour schedule meticulously planned. Backup teams ready for any contingency. Timeline of the miracle. Sunday, 12:01 a.m., November 8, 1942. Keel laid. Floodlights illuminated the entire yard like daylight. 8 a.m., first transverse frame erected. 500 welders began work. 4 p.m., entire hull framework complete. Deck steel plates being lowered by cranes. Monday, November 9, hull plating completed. Engine, weighing 140 tons, lowered into position by giant crane. Tuesday, November 10, cabins, piping systems, electrical systems installed. Funnel welded into position. Wednesday, November 11, deck equipment, lifeboats, anti-aircraft guns installed. Painting begins. Thursday, November 12, system checks, engine started for first time. Friday, November 13, 10:30 a.m. After 4 days, 15 hours, and 29 minutes from keel laying, SS Robert E. Peary slid down the ways and was launched. The crowd of several thousand who witnessed it applauded like thunder. Journalists stood stunned. Delegates from Washington couldn't speak. A complete Liberty ship, ready to sail immediately, built faster than the time most people took to do the paperwork to buy a ship. Technical details of the record. Total man-hours, 470,000 hours. Number of workers, 4,500 people. Number of shifts, 3 shifts daily, 24/7. Weight of steel welded, 4,100 tons. Length of welds, 50 miles, 80 kilometers. Cost, $2 million USD, equivalent to $35 million in 2024. Chapter 5. Kriegsmarine's reaction, from skepticism to horror. Stage 1. Skepticism, 1941 to early 1942. When the first intelligence reports about Liberty ships reached Berlin in late 1941, the initial reaction was laughter. Fregatin Captain Hans Meckel, senior naval intelligence officer at OKM, Oberkommando der Marine, German Naval High Command, wrote in his January 1942 report, "Sources from Washington report that the Americans claim they will mass-produce merchant ships using assembly methods. They talk about welding instead of riveting, about producing rather than building ships. This is clearly propaganda intended to deceive us about their true capacity. Every naval engineer knows that welded ships cannot withstand the pressure of the North Atlantic. We should ignore these exaggerated claims." Even Dönitz, the wisest of German admirals, was skeptical. In a March 1942 meeting with Hitler, he reported, "Mein Führer, our intelligence indicates the Americans claim they will produce 500 merchant ships this year. This is an impossible number. Even if they double their efficiency, they can only build 150 to 200 ships at most. Our U-boats are sinking ships much faster than this rate." Hitler replied, "The Americans are good at propaganda. They want us to believe they're stronger than they actually are. Continue the U-boat campaign." Stage 2. Realizing the truth, mid-1942. But by summer 1942, the truth could no longer be denied. Corvettin Captain Reinhard Hartigan, commanding U-123, conducted one of the most successful patrols in the U-boat campaign, Operation Drumbeat Paukenschlag, along the U.S. East Coast in early 1942. He sank 9 ships totaling 50,000 tons in just one patrol. When he returned to base at Lorient, France in June 1942, he was awarded the Knight's Cross. But in his classified report to Dönitz, he wrote something that shocked the Admiral. "Her Admiral, on this patrol, I observed 47 American merchant ships. Remarkably, 23 of them, nearly half, appeared to be the same design. They were identical to an uncanny degree. Simple design, boxy, no decorative details. All had 3 masts, same superstructure arrangement, same funnel position. This cannot be coincidence. The Americans must be producing them from the same template like manufacturing automobiles. I fear the reports of their mass production may be true." Dönitz ordered verification. Reports from other U-boats confirmed identical ships were appearing everywhere. In July 1942, the Abwehr, German intelligence, finally obtained documents about the Liberty ship program. The report was shocking. America had built 8 new shipyards, each yard capable of launching 1 to 2 ships per month. Estimated total output 300 to 400 ships per year. Design completely standardized, using welding instead of riveting. Construction time 60 to 90 days per ship. Fregatin Captain Gunther Hessler, Dönitz's son-in-law and chief of staff, analyzed the numbers and reached a terrifying conclusion. If these numbers are accurate, we are losing the production race. Even if we double our U-boat numbers, we cannot sink ships faster than the Americans are building them. Dönitz refused to believe it. He ordered re-verification. The numbers were confirmed. And then it got worse. Stage 3. Horror 1943. 1943 turned skepticism into horror. Returning U-boats continuously reported the same story. They sank ships, but there were more and more ships. New ships, fresh from shipyards, paint still shiny, no rust. In March 1943, in the largest convoy battle of the Atlantic War, 40 U-boats attacked two convoys, SC-122 and HX-29. In 5 days of fierce fighting, U-boats sank 21 merchant ships, totaling 141,000 tons. This was a resounding tactical victory for Dönitz. German press hailed it as the greatest U-boat victory. Hitler personally congratulated. But Dönitz wasn't happy. In his private diary, he wrote, "We sank 21 ships, but intelligence reports that in March alone, the Americans launched 43 new Liberty ships. Combined with ships from Britain and Canada, the Allies added 60 ships this month. We are sinking 1/3 of what they produce. The mathematics is simple but brutal. We cannot win." In May 1943, the situation became desperate. During this Black May, 41 U-boats were sunk, a loss rate of nearly 30%. Dönitz was forced to withdraw all U-boats from the North Atlantic. In a meeting with Hitler on May 31, 1943, Dönitz had to admit defeat. "Mein Führer, we have lost the Battle of the Atlantic. Not because the British defeated us in combat, though they have improved greatly, but because the Americans beat us in production. They are launching ships faster than we can sink them, and that is a race we cannot win." Testimony from survivors. Captured U-boat officers provided profound testimony about the psychological impact of Liberty ships. Oberleutnant zur See Wolfgang Luth, one of the most successful U-boat commanders with 47 ships sunk, in interrogation after capture in 1945, said, "Sinking a Liberty ship no longer brought any feeling of victory. There were too many. Like cutting off the Hydra's head. Cut one, two grow back. I sank 3 Liberty ships in one patrol in November 1943. A month later, I encountered a convoy with 7 new Liberty ships. Where did they come from? Who was producing them? It was like black magic." Captain Lieutenant Herbert Werner, author of the famous memoir Iron Coffins, wrote about his experience. "We were trained to think that each ship sunk was a victory, a step closer to final victory. But by 1943, we knew the truth. Those simple, ugly ships, Liberty ships, they were immortal. You sink one on Monday morning, by Tuesday afternoon, 2 more have replaced it. This was no longer war. This was industrial slaughter, and we were the ones being slaughtered." Corvette Captain Peter Creamer, commanding U-333, in a 1995 interview, "The problem with Liberty ships wasn't that they were good. They weren't good. They were slow, easy to detect, easy to sink. The problem was they were everywhere. You sank them like shooting fish in a barrel, but the more you shot, the more fish there were. It was a nightmare." And in Chapter 6, The Undeniable Numbers. To understand the scale of American achievement, consider the numbers. Liberty ship production, 1941. Ships completed, 1. SS Patrick Henry. Average time, 244 days per ship. 1942. Ships completed, 597. Average time, 70 days per ship. December rate, 3 ships per day. 1943. Peak. Ships completed, 1,191. Average time, 42 days per ship. Highest rate, 5 ships per day, August. Record, SS Robert E. Peary, 4 days, 15 hours. 1944. Ships completed, 732. Average time, 30 days per ship. 1945. Ships completed, 213 through September. Total, 2,751 Liberty ships. Comparison with German predictions. Dönitz prediction, early 1942. America could produce maximum 150 to 200 ships year. Reality, 1942, 597 ships, 3 to 4 times prediction. 1943, 1,191 ships, 6 to 8 times prediction. Total tonnage. Each Liberty ship, 10,500 tons cargo. Total, 28,905,500 tons carrying capacity, equivalent to the entire world's merchant fleet in 1939. Sinkings versus production. 1942. U-boats sank 1,664 ships, 7.8 million tons. U.S. plus U.K. plus Canada produced 8.1 million tons. Result, Allies plus 300,000 tons. 1943, U-boats sank 812 ships, 3.6 million tons. Allies produced 14.2 million tons. Result, Allies plus 10.6 million tons. By the end of 1943, the Allies had more merchant ships than when the war began, despite losing thousands of ships. Cost. Each Liberty ship, average cost $2 million USD, 1943. Equivalent, $35 million USD, 2024. Comparison. One heavy cruiser, 50 to 60 million USD, 1943. One aircraft carrier, 70 to 100 million USD, 1943. Operating cost of one U-boat per year, $3 to $4 million. Economic efficiency. To sink one Liberty ship, the Kriegsmarine on average had to lose one U-boat, construction cost $4 million. Lose 50 trained sailors. Expend 20 torpedoes, $50,000. Result, spent $4.05 million to destroy $2 million worth of assets, and the ship would be replaced in 30 days. Workforce. Peak production 1943. Shipyard workers 700,000 people, of which women 250,000, 35%. Average age 28 years. Workers who had never built ships before the war 85%. Training. Welder training time 2 to 4 weeks. Crane operator training 1 to 2 weeks. Compare traditional riveter 2 to 4 years. Shipyards. Before war, 1939, America had 7 merchant shipyards. During war, America built 18 new yards just for Liberty ships, 6 Kaiser yards, California, Oregon, 4 yards in Maine, 3 yards in Baltimore, 5 other yards along coasts. Each yard had 6 to 12 launch slipways, 100 cranes, capacity 2 to 4 ships per month. Yard construction time. Kaiser built Richmond Shipyard No. 2, one of the world's largest shipyards, in 6 months. Compare, Germany took 2 to 3 years to build a submarine yard. Chapter 7. Technology and Innovation. Welding, the silent revolution. The Liberty ship was the first mass-produced welded ship in history. This was a technological leap few recognized the importance of. Initial problems. Traditional shipbuilders were right to warn about welding dangers. The first welded ships did have serious problems. 1. Brittle fracture. In the cold water of the North Atlantic, some welded ships suddenly cracked. Not small cracks, entire hulls split in two. SS Schenectady broke in half while moored at port, January 1943. SS Esso Manhattan, large crack on deck, nearly sank, March 1943. At least 19 ships severely damaged by welding cracks. German reaction. We told you so. Welding is unsafe for seagoing vessels. Kriegsmarine statement, March 1943. For a time, Germans believed Liberty ships would self-destruct without needing U-boats. They were wrong. American solution. Instead of abandoning welding, America 1. Scientific research. Constance Tipper, British metallurgist, discovered the problem. Phase transition of steel at low temperatures. American engineers developed new alloy steel with better resistance to brittle fracture. 2. Design improvements. Added crack arresters, riveted steel plates at high stress points. Rounded square corners to reduce stress concentration. Reinforced watertight bulkheads. 3. Improved welding process. More precise temperature control. Better welders training, stricter quality inspection. Result, by late 1943, the brittle fracture problem was solved. Failure rate dropped from 3% to 0.5%. More importantly, Americans learned and applied this lesson to all subsequent ships. Welding became the standard method for modern shipbuilding. Prefabrication, amazing level of detail. The level of prefabrication in Liberty ships far exceeded what Germans imagined. Specific example, captain's cabin. Instead of building the cabin on the ship, a separate factory in Oakland produced complete steel walls with sound insulation, polished teak wood floor, ceiling with electrical conduit and lights pre-installed, windows with shatterproof glass already fitted, built-in wardrobes, fixed bed and desk, air conditioning system, complete plumbing and sink. The entire cabin, weighing 18 tons, was transported by truck to the shipyard, lifted by crane, and lowered into exact position. Welders only needed to weld 4 joints and connect electricity and water. Total time, 3 hours. Compare, building the same cabin traditionally on ship, 2 weeks. Engine module. The triple expansion steam engine wasn't assembled on the ship. It was completely assembled at the engine factory in Pennsylvania. Test run, then transported intact to California by rail. Weight, 140 tons. Size, 20 feet by 15 feet by 25 feet. Installation time on ship, 8 hours. Piping systems. Instead of bending and welding pipes on the ship, pipe sections were prefabbed. Each pipe section cut, bent, and welded in separate factory. Each section numbered according to blueprints. Installed on ship like Lego assembly. 15 miles, 24 kilometers per ship. Installation time reduced from 6 weeks to 4 days. Tools and machinery. Kaiser shipyards were equipped with the most advanced tools of the time. Giant cranes. 50 cranes per yard, each capable of lifting 150 to 200 tons. Some cranes could lift up to 300 tons. Electrically controlled, accurate to the inch. Cost per crane, $500,000 USD, 1943. Welding machines. 5,000 electric welding machines per yard. Each yard consumed electricity equivalent to a city of 50,000 people. Automatic welding machines for long straight welds. Cutting machines. Plasma cutting machines, newly invented. Oxyacetylene cutting machines could cut 3-inch thick steel at 12 inches per minute. Bending machines. Giant hydraulic bending machines could bend 40 feet by 8 feet by 1-inch steel plate. Accuracy, 1/16 inch. Chapter 8. The People Behind the Miracle. Rosie the Riveter, the real symbol. One of the biggest social changes was women's participation. Before the war, women in shipbuilding 1%, mostly clerical work. During the war, women 35% of shipbuilding workforce. Many yards had more than 40% women workers. Did all jobs, welding, crane operation, riveting, quality inspection. Wendy the welder. One of the best welders at Richmond Shipyard was a 23-year-old woman named Helen Wendy Studer. She had never worked in a factory before. She was a kindergarten teacher. After 3 weeks of training, she became a first-class welder. She held the record for most quality welds in a single shift, 687 welds in 8 hours. When asked her secret, she said, "I treat every weld as if my son's life depends on it. My son is fighting in the Pacific. I want to ensure the ships carrying supplies to him are as solid as possible." Individual records. Jimmy the Quick. James J. Kovacic, 19-year-old crane operator, held the record for fastest module placement. 47 modules in one 12-hour shift, averaging 15 minutes per module. 6-Gun Sally. Sarah Thompson, 35-year-old welder, nicknamed 6-Gun because she could use 6 different welding machines. She designed a system to quickly switch between weld types, increasing efficiency 40%. Old Man River. Robert River Johnson, 62 years old, quality supervisor, inspected over 300 Liberty ships. He could detect poor quality welds just by touch. "I can feel the wrong vibration," he explained. He prevented 43 potentially serious crack cases. Stories from workers. Mary Eleanor, welder, 24 years old, in letter to husband fighting in North Africa. "My darling, today I completed the final weld on SS John Muir. That's the 17th ship I've helped build. When it slid into the water, I cried, not from joy, but because I thought that maybe one day this ship will bring you home. Every weld I make for you." Joseph Romano, 19 years old, crane operator, in his diary. Day 47 working at the yard. Today I placed the engine into position on SS Benjamin Franklin. 140 tons of metal suspended in air, 30 feet above the ship's deck, had to lower precisely into a space only 3 inches wider than the engine on each side. My heart pounded like a drum. My hands were sweating, but I did it. 8 minutes from lift to placement. The foreman said it was a new record. I'm 19 years old and I'm helping win the war. Workforce diversity. An often overlooked aspect of the Liberty Ship program was the unprecedented diversity of the workforce. African Americans, 15% of workforce, about 100,000 people. First time hired for high-skilled technical positions. Received equal pay with white workers, very rare at the time. Kaiser fought against discrimination in his yards. Joseph James, African American welder, 31 years old. I was born in Mississippi, where black people weren't allowed to touch complex machinery. They said we weren't smart enough. Now I'm welding the most critical joints on ships, the ones that hold the hull together. Mr. Kaiser says he doesn't care about skin color, he only cares about quality work, and I do the highest quality work. Mexican Americans, 8% of workforce at California yards. Many migrants from southern states seeking work, paid fairly for the first time. Asian Americans. Despite Japanese Americans being interned, many worked in shipyards before being taken away. Chinese Americans, 5% of workforce at West Coast yards. People with disabilities. For the first time, people with disabilities were hired for industrial jobs. Deaf people worked well in the noisy shipyard environment. One-eyed people could still do many technical jobs. Leg disabilities worked at positions not requiring much movement. Work culture. Kaiser created a unique work culture. Healthcare. Kaiser established clinics at yards, precursor to Kaiser Permanente, one of America's largest healthcare systems today. Workers received free medical care, accident insurance, maternity care for women, child care. Kaiser's yards were among the first to provide on-site child care, 24/7 daycare for all shifts, free meals for children, professionally trained teachers. Food. Yard cafeteria served 10,000 meals a day. Subsidized prices, 25 cents for a full meal. Open 24/7 for all shifts. High quality. Kaiser believed well-fed workers worked better. Wages. Average wage, $1.20 per hour, 40% higher than industrial average. Performance bonuses. Overtime paid at 1.5 times. No discrimination by gender or race. Chapter 9. Strategic Impact. Changing how war was fought. Logistics. The lifeblood of victory. Liberty ships didn't just transport goods, they changed the entire strategy of war. Before Liberty ships, generals had to plan based on limited logistics. How many ships do we have? How long to transport a division? If we lose 10% of ships in transit, will we have enough to fight? After Liberty ships, logistics was no longer the main constraint. How many ships do we need? Okay, we'll build them. Strategy no longer limited by transport capacity. America could plan simultaneous campaigns on multiple fronts. Staggering transport numbers. From 1942 to 1945, Liberty ships and other American merchant vessels transported military personnel, 7.5 million soldiers across the Atlantic, 3.2 million soldiers to the Pacific, not counting internal movements. Cargo, 268 million tons of war supplies, including 16.5 million tons of ammunition, 43 million tons of fuel, 18 million tons of food, 7 million tons of vehicles and machinery, 183 million tons of other goods. Equivalent, enough to fill 10 million 20-foot containers. A train 500,000 miles long could circle the Earth 20 times. Every man, woman, and child in America could receive 2 tons of goods. Lend-Lease, saving the Soviet Union. One of the most critical strategic impacts of Liberty ships was the Lend-Lease program with the Soviet Union. Murmansk route. Liberty ships transported to the Soviet Union 7,000 tanks, 14,000 aircraft, 51,000 jeeps, 375,000 trucks, 2.3 million tons of ammunition, 4.5 million tons of food. Stalin later admitted, without America's Liberty ships, we could not have won. The price paid. The Murmansk route was the most dangerous. 77 Liberty ships sunk on this route. Convoy PQ-17, July 1942, 24 of 35 ships sunk. Water temperature -2 degrees to 2 degrees. Sailors survived only 15 minutes if they fell overboard. But the ships kept coming. Each ship sunk was replaced within a week. Operation Overlord, D-Day. Liberty ships were the backbone of history's largest invasion. Preparation phase, January to May 1944. 900 Liberty ships transported supplies to Britain. 5 million tons of military equipment. 1.5 million soldiers. Daily, 30-40 Liberty ships arrived at British ports. D-Day and after. 350 Liberty ships directly participated. Transported 50,000 vehicles in the first month. 100,000 tons of ammunition per week. 2 million tons of fuel in first 3 months. General Eisenhower said, "Every Liberty ship that arrives is a division that can enter combat." Pacific, Island Hopping Campaign. In the Pacific, Liberty ships enabled a strategy the Japanese never imagined. Island hopping. Instead of attacking each island in order, America could bypass fortified islands, cut off their supply lines, and attack weaker islands. This was only possible if America had sufficient logistics capacity to maintain distant bases. Numbers. A typical island hopping campaign required 200,000 tons of supplies. 20-30 Liberty ships. Could be repeated every 4 to 6 weeks. The Japanese calculated based on traditional logistics. They thought America needed 6 months to prepare between landings. America did it in 6 weeks. Comparison with Germany. German logistics. Kriegsmarine had 260 merchant ships in 1942. Production 30-40 ships a year. Most destroyed by Allied air forces. By 1944, only 80 ships operational. Consequences. Rommel's Afrika Korps suffered defeats partly due to supply shortages. Wehrmacht in Eastern Europe often lacked ammunition, fuel. Could not maintain multiple fronts simultaneously. A captured German officer said, "We fought a 19th century war with 21st century weapons. The Americans fought a 21st century war with 21st century logistics." Chapter X, Special Ships, Liberty Ship Variants. Liberty ships weren't just ordinary cargo vessels. They were modified for dozens of different purposes. Floating repair ships, SS Vulcan class. 15 Liberty ships converted to floating repair yards. Equipped with full machine tools, lathes, milling machines, welding equipment. Could repair ship engines, guns, radar. Each ship had 200 technicians. These ships allowed the U.S. fleet to stay far from bases for months. Damaged ships didn't need to return to port. The repair yard came to them. Hospital ships, SS Mercy class. 24 Liberty ships became hospital ships. 500 beds per ship. 5 operating rooms, X-ray rooms, laboratories. 50 nurses, 20 doctors. These ships saved tens of thousands of soldiers' lives. Aircraft carriers, SS Aircraft Transport. 100 Liberty ships converted to carry aircraft. Decks reinforced to handle aircraft weight. Each ship carried 30 to 50 fighter planes, disassembled, or 15 to 20 bombers, disassembled. Tankers, SS Tanker Conversion. 200 Liberty ships converted to oil tankers. Cargo holds made watertight and oil-resistant. Each ship carried 10,000 tons of fuel. Most dangerous, one torpedo could turn ship into a fireball. Rocket ships, SS John W. Brown rocket launcher. One of the strangest conversions. 4 Liberty ships fitted with rocket launchers. Each ship could fire 500 rockets in 30 seconds. Used for amphibious assault support. Effectiveness equivalent to an artillery battalion. Command ships, SS Command Ship. 10 Liberty ships became floating command centers, equipped with powerful radios, radar, meeting rooms, combat information centers, allowed campaign command from the sea.